Hey, welcome back. This is Trig, and we're going to review for test 3 and give you a good idea of what's going to be on the test. So remember, you're allowed to use my formula sheet on this test, and some of the formulas you probably won't need, but some you will, so you'll kind of have to, hopefully you've already been using it to do your homework and that sort of thing, so hopefully you're familiar with it. I'll be referencing this sheet throughout the video. Anyways, you will have that sheet on the test. Okay. So the first section we covered was 6.1, and we were working on solving right triangles, or not right triangles, but oblique triangles, right? And we needed a set of formulas called the law of sine formulas. And I'll be picking problems like 9 to 31 odd. And so any kind of those problems is up for grabs, so to speak. Let's just look at kind of go through each scenario and see what you're up against. So number 10, they give you the angle A is 56 degrees, the angle C is 24 degrees, and then side A is 22 units, so you can go through and kind of draw your triangle. So again, it's always A, B, C, going kind of counterclockwise there. This will be little C, this will be little a, this will be little b. We know A is 56, we know C is 24, and we know A is 22. Okay, so the lowest hanging fruit is that angle B. Just from our knowledge of triangles in general, we can get angle B by subtracting, taking 180 and subtracting away the two angles that we know. Okay. So doing that will give us, I believe it's 100 degrees. 6, 4, and, 0, 1, 6, 7, yeah, 100 degrees. Okay. Once you get that, then you could use the law of sines to kind of chip away at the other unknowns. So I'll start by just, working with the A values, because I know the angle and the side A. So we have 22 all over sine of 56. And on the other side, you could, get a length B or a length C. I'll get length B first. So B all over the sine of 100. Okay, and then you just multiply both sides by a sine of 100. So B equals 22 sine of 100 all over sine of 56. Okay, please show your work on your test. Don't just write the answer. What is this thing? If you put this in your calculator, make sure you're in degree mode. You'll end up with 26.1 for that side. And I'll tell you how many decimals. Traditionally, you round to the nearest degree, but sometimes I notice in the book that's not always the case. But traditionally, round to the nearest degree, and then for the lengths, it's the nearest tenth. Okay, so you just do one decimal place. Let's get our hands on the final unknown, which is the C value. So again, we'll work with the A. Little a and big A, we know that, and then on the other side we'll put little c, and then we know big C is 24. Again, just multiply both sides by sine 24, you get 22 sine 24 all over sine of 56, and dump that into your calculator, make sure you're in degrees, and I got 10.8. You can verify that with your calculator. Make sure you're doing it correctly. Okay, so there's one variation. I mean, most of these are kind of just the same, but then there's those weird ones where you have two possible solutions, or one possible solution, or no possible solutions. Okay. Let's look at one more of the traditional ones. So this is number 15. And they give you A is 65 degrees, and then big B is 65 degrees, and then little c is 6. Okay, so you can set up your triangle here and see what you're dealing with. Big A big B. Whoops, yeah, I always put those counterclockwise. Sorry, big B, big C. So this is little c, this is little a, this is little b. This is 65 degrees. B is also 65 degrees. They also give us C is 6. Okay. So angle, side angle. I don't really memorize, all the angle, side angle, side angle. For the law of cosines, you kind of need to remember those, the side, and then the side angle side. But for these, they're kind of, you'll be forced to do one method or the other, and you're kind of consider yourself you're foraging for food, and you'll take anything you can get, in archaeology or in, what is that, optimal forager or something. I don't know what they call it in biology, but here again, I mean, look, the lowest hanging fruit is that C angle. And that's easy to get. You don't have to pull out any huge. So even if I didn't know what the formula was, I would, whether it's side angles, if I didn't know any of that, I would still do this. It just makes sense. So 180 minus 65 minus 65, and that's going to give you 50. I don't know why I'm writing 90, but it's 50 degrees. Okay. And then you can use your law of sines to get the other ones, because you'll have the C is 6 all over sine 50, and then we don't know like one part of the other side. So in particular, we could do A first, A all over sine of 65, and then multiply both sides by sine of 65, and you get A is 6 sine of 65 all over sine of 50. Plop that into your calculator, make sure you're in degree mode, and you'll get, I'm looking 7.1 approximately. Okay. All right. Then thirdly, what is left? Little b. So we have then 6 all over sine 50 equals little b all over sine of 65, and multiply both sides by sine 65. Little b equals 6 sine 65 all over sine of 50. And then get an approximation. Again, that turns out to be 7.1, believe it or not. Okay, so these are kind of the standard issue, and you should start, just logically looking for something easy to do. And if you do it in that approach, then there's not much of a question as to, oh, I should do this, or oh, I should do this. Okay. Let's look at number 18, and now we start looking at the problems where the law of sines will result in more than one solution. And I've kind of noted that on my tests. So when you see side angle, you're going to have the 0, 1, or 2, and your method is going to have to be different. Okay, so for these first two problems, so angle, side angle was this one, angle, side angle, and then this one is also, I guess, angle, side angle. I guess I didn't put one of the other ones in there. Side angle will also be of that form. And you see in these first two, you have two of the angles, and you just need the third one. So you're always starting with that 180 degrees minus the other angles, right? And then you use law of sines to chop away. This SSA, you'll have your formula sheet, so you'll know this is one of the weird ones where you can have multiple solutions. But let's take a look. B is 20, and then angle A is 50 degrees. So go to your triangle and set it up. A, B, C. This will be little a, little b, little c. And they're telling us A is 30, little b is 20, and angle A is 50. So there's no way to kind of get the low-hanging fruit again. You're stuck with something else. If you look at the form and you read off the given information, it looks like it's going side angle, or angle side side angle, or angle side. That has to be this one right here, and that's one of the weird ones, right? So you'll have to start with something else, and that something else is just straight up using your law of sines. So you have the 30 for little a and then 50 for big A, so you kind of set that up. And then on the other side, you can go after angle C or angle B, right? The book doesn't really specify which angle you should go after. I'll just go after angle B. Let's keep it in alphabetical order. So little b is 20, and then well, I guess we didn't even know. Yeah, I mean, we don't know little c and big C at all. So you're forced to do the b value here. That you have no choice. So anyways, you'll have sine of b, which we don't know, and this is what's causing the issue with the multiple solutions, is when you take that inverse sine. Okay. We don't really know if it's an acute angle or obtuse. But anyways, solving this thing, so basically multiply both sides by sine of b, and then multiply both sides by the reciprocal of 30 over sine 50. You get 20 sine 50 all over 30. Okay, and then take sine inverse on both sides to get rid of the sine in front of the sine of b. Okay, now the sine inverse. 20 sine 50 all over 30. So this will be b equals whatever this thing is. Again, make sure you're in degrees. You'll get one answer. In this case, if you put in your calculator, it'll just give you 31 degrees. And then you kind of have to turn it into two problems at that point. So you have this one is b equals 31 degrees. And then kind of you have the other guy, B2 is 180 minus 31 minus, what are the other ones? 180 minus, yeah, the B2 is just 180 minus 31, sorry. It's getting carried away. And the problem is here, when you do that computation, it's not going to work, right? So B2 would equal 149, which just won't jazz with reality. Okay, so B2 in that case would be 149, and then if you tried to find the corresponding C value, you have to take 180 minus 149 minus 31, and you're out of luck. Okay. Right, because that thing is just going to be negative. What is it? -8. Okay. So this isn't one. That's not going to work. So you're just going to have the one answer case. Let's get that answer. So once you get B1, you get some low-hanging fruit with the C2. That's just 180 minus 31 minus 50, and put that in your calculator. Maybe minus 31 minus 50, that should be 99 degrees. And then thirdly, you can go ahead and find whatever's missing. So what was missing here? Do we have little b yet? Yeah, we have little b. Little c, I guess, is what's missing. So you can use the information you have. So 30 all over sine 50 from the little a and big A values. And on the right side, put little c and then sine of 99. Okay. Then you should be able to multiply both sides by sine 99, and c will equal 30 sine 99 all over sine of 50. Sorry about my handwriting. In that case, it's to one decimal 38.7. Okay. Okay. Let's look at the other two cases of this kind of problem. So let's look at number 23. And they give us little a is 10, little b is 40, and then little big A is 30 degrees. And I draw the picture. The picture helps you kind of identify which type you're actually dealing with. I mean, clearly this is some sort of side-side angle. But if you look at the formula sheet, there's this SAS or is it SSA? That becomes the question. But if you draw the thing out, and there should be no guessing after you draw it out. So little a, little b, and then little c, big A is 30, little b is 40, little a is 10, and we're looking at angle side side, or if you'd rather side side angle. Okay, and side side angle, so it's definitely not side angle side. It's not this case here. So it's side side angle, or if you'd rather angle side side, and you see that there's only one possibility. It's the 0, 1, or 2 side solution case. So okay, we can't go after low hanging fruit. We're going to have to do something drastic, and the only thing you can really do is go to the law of sines and go 10 all over sine of 30. And then on the other side, you can go after angle B, right? Because you know the side 40, and then you're just left with solving this one equation, one unknown, right? Okay, so multiply both sides by sine B, multiply both sides by the reciprocal of 10 over sine 30. You get 40 sine 30 all over, I guess just 10. Take sine inverse of both sides. And when you plug that in your calculator, you're going to get an error message. And it's because this thing right here is, well, we can figure out what that is, right? It's 4 times the sine of pi over 6, which is 1/2, which is 2. You can't take sine inverse of 2. 2 is not going to work in your calculator. So there is no b value here, and that's the case where this b does not exist, basically. So this is the case where there's no triangle. Okay, so you could say hence no triangle. Just write no triangle is good enough. Okay, so those are the cases where it's best because you have less work to do. The two answer triangle is always kind of the most annoying, and I'll put, maybe I'll put one of these on the test, but let's set it up and see what we're looking at, right? So again, get a drawing so you can see, is it going to be the SAS or is it SSA, right? We need to figure out kind of the ordering because we had 2 sides and 1 angle. Okay, but it's A, B, C, angle is 20, little a is 30, little b is 40. So it looks like it's angle side side going counterclockwise there. So, or side side angle if you go always in this direction. I think maybe that's the way they're doing it. They're always go counterclockwise in the same way we do ABC. But regardless, you're not going to be able to confuse it. There's just no way to screw it up, really. There's no other kind of triangle that has 2 sides and 1 angle that's in this ordering. Okay, so side side angle, or to say it was side angle side, you would have to skip this one unknown side. You'd have to skip side C. Okay, so hopefully that's clear how that works. But anyways, again, you're stuck. No low-hanging fruit, so you're going to have to work with the law of sines. You got 30 all over sine 20. And then on the other side, that will be, we'll have to go after sine B, right? So you'll have 40 all over sine of B. Isolate sine of B. So 40 sine 20 all over 30. And so B, you go to your calculator, will be 27 degrees. And that's our first B. Or B2 will be 180 minus 27, which gives out 153 degrees. Okay. So it looks like we have 2 possible triangles. We'll start with B1 is 27 degrees, and then over here I'll put B2. Okay. It's 153 degrees. Okay. So once you get B1, you can get the low-hanging fruit of C1. Okay, so C1 will be 180 minus 20 minus 27, and so C1 is 133. And then we could find little c using the law of sines. So I'll just work with the a values, 30 all over. So this would normally be step 3 in my work. You don't have to write the steps out, though. Please have some ordering. Don't just throw a bunch of stuff at the page. So anyways, 30 all over sine 20 equals the unknown little c all over sine of 133. And then you can solve for c by multiplying both sides by sine 133. You get 30 sine 133 all over sine 20. We want one decimal place, so in this case 64.2. Okay. Go get the other guy then, so C2 will be 180 minus 20 minus 153, assuming that works, right? Because on the test you're not going to know if it works or not, you just have to test it and make sure it's not like giving you a negative answer. So 180 minus 20 minus 153 is, and yeah, it works. It's a small angle, but it still works. So 7 degrees. Then use your law of sines, right? So 30 all over sine 20 equals little c all over sine of 7. Solve for c. So c will be 30 sine 7 all over sine 20. Okay. Going to my calculator. Looks like I'm getting 10.7. Okay. Okay, so those are rather annoying. Let's move on to 6.2. This is where we get the law of cosines. And you see there's only 2 types. If it's SSS, you automatically know it's law of cosines, right? And there's only one SSS. There's no way you can screw that up with a law of sine problem. So it's either SSS or it's SAS. In order to know whether it's one of these SSA or is it SAS, usually you just draw the picture and work your way around the triangle and see which it is, right? So 6.2, I'm looking at problems like 9 to 23 odd for your rehearsal problems. Let's look at number 13, where they give us 2 sides and an angle. So A is 6, C is 5, and then angle B is 50 degrees. I draw it out to make sure it's not the side-side angle or some other weird, the only other possibility could be side-side angle, right? So let's go to the picture. Yeah, it's A, B, C. Little a is 6, little c is 5, and b is 50 degrees. So it's clearly side, angle, side. There's no way to interpret it any other way without kind of skipping an angle or a side. So I have to use the side, angle, side method. So that's going to start with your law of cosines. And we'll look back to the paper for step 2. Okay? So you're forced to use a particular law of cosines. All right. And in particular, it's the one that because you only have certain bits of information, right? You only have little a, little c, and big B. And the only formula that contains all 3 of those items is going to be the one that has cosine of angle B on it, right? So then you just kind of back engineer. This will be minus 2ac, and then it will be a squared plus c squared, and of course that'll equal little b squared. Okay, so it's the only law of cosines formula that has that particular angle that you're given. Okay, so you're forced to use that particular guy. All right, so anyways, let's solve that. So I have b squared is 36 plus 25 minus 60 cosine of 50. I'm going to take the square root on both sides and plop it into my calculator. What is it? 61, carry the 1, 3, 4, 5, 61 minus 60 cosine 50. Okay, I'll go to my calculator and see what I get. 61 minus 60. Make sure you're in degrees. I'm getting 4.73 Okay, so 1 decimal place, 4.7. Okay, let's go back to the formula sheet. So first do law of cosines, and secondly you do a law of sine to find the angle opposite the shorter of the given sides. So right now our sides are A is 6, C is 5, and then B is 4.7. So the shorter of the given sides, whoops, you would think would be that B is 4, but it's the given sides they're talking about. So you really don't even need to think about the side you just created. The shorter of the given sides, so these are the given, let me underline the given sides. Okay. The shorter one is angle side C. So that's the one you go to. That's what that means. It doesn't mean include the side B. Okay. It's the given sides. So step 2, we use your law of sines. So I'm going to go with the 4.7 and 50 for, I mean, that's the only thing I can do at this point because I don't have the other angles. So 4.7 all over the sine of 50. And then on the right, I have 5 all over sine of C, big C. Okay. And then you're going to have to do some inverse sines eventually, but you'll have sine of big C equals 5 sine 50 all over 4.7. Inverse sine on both sides gives you, I'm going to my calculator, gives me to the nearest degree 55 degrees. Okay. Then you got some low-hanging fruit, right? If you need angle A, you just use the 180 formula. So A is 180 minus 50 minus 55, and that part's easy. Okay. So what is that? 75 degrees. Okay. Okay. The last type then is a side. And there's no way to confuse that. That's automatically going to be your law of cosines. So A is 3, B is 9, and C is 8. If you look at the formula sheet side, use law of cosines to find the angle opposite the long side. So you find the long side, that's this. If you draw a picture, you note the angle opposite that side is angle B. So you have to use the cosine formula that has cosine of B. And again, there's only one of those, so it would be 2 minus 2 AC, and then you have A squared plus C squared, and on the other side, little b squared. Okay. We can still draw the picture if you're not entirely convinced. A, B, C, and then little b is 9, little a is 3, and little c is 8. Okay? So the angle we want to first go for is the one opposite the longest side. Okay, so let's plug and chug. B squared is 81, and then we have 9 plus 64 minus 3 times 8 times 2, so 24 times 2 is 48 cosine of B. I'm going to move the 48 cosine B to the other side, and then subtract the 81 to the other side. 9 plus 64 minus 81. Yeah, I think it's 8. Let me check. 9 plus 64 minus 81. Yeah, negative 8 actually. Is it negative 8? Yeah, it's going to be negative. Okay, divide both sides by 48. Cosine of B is basically negative 1 over 6. And then take cosine inverse on both sides. Let me go on my calculator again. Cosine inverse of negative 1/6. Yeah, it looks like 99.6 degrees. But to the nearest degree, you have to round up to 100 degrees. Okay, let's go back to the formula sheet then. Your second step, you use law of sines. I guess we could go after either angle A or angle B. I'll just go after angle A or angle C. I'll just go after angle A. alphabetical order here. So I have law of sines, then 9 all over sine of 100 equals what did I say? The A. I want to do the A value. So 3 all over sine of big A. So solve for sine of A. Get sine of A equals 3 sine of 100 all over 9. Take inverse sine on both sides, and you'll get A is approximately 19 degrees. Then you got some low-hanging fruit, right? So angle C will just be 180 minus 100 minus 19, which I think is 61 degrees. Okay. Okay, so expect a whole ton of those. From there, we went into the polar coordinate system, working with problems from 6.3. So in particular, I'll expect to be able to do problems like 33 to 73. So basically doing conversions, converting from polar to rectangular, rectangular to polar, with coordinates, and then also with equations. Okay. So first, let's go from polar to rectangular coordinates. And in order to pull this kind of stuff off on the formula sheet, you basically need the stuff in this box down here. Okay, the x equals r cosine theta, that kind of stuff. So anyways, let's go to 35. 2 comma pi over 3, and I want to convert that into the rectangular coordinate system. I like to draw a graph. In the other version, when you go the rectangular or the polar, you have to draw the graph. But here, you might as well. So let me see if I got somebody in my office hours. Oh, hold on. Okay, so I graph it, and 2 pi over 3. So where's pi over 3? Pi over 3, I rotate over to about right here. And then I have to go out 2 places on these concentric circles, so it'll be the point will be right there. So anyways, in these problems you don't really need to graph it, but I just like to always do it in case I need it. The x and the y value will be from the r cosine formula, so don't accidentally put sine. It's r cosine, and then y will be r sine. So what do we have here? X is equal to 2 cosine of pi over 3, which is basically 2 times 1/2, which is 1, so 1. And then y equals 2 sine of pi over 3, and then you get the, your radical 3 over 2 kind of thing. All over 2, and then the 2's cancel, and you just get radical 3. Okay, so simple enough. Let's go in the other direction then, and now we have to use like the tan formula and the Pythagorean formula. This is problem 43. I start in rectangular, so 2 comma negative 2 root 3. And I want to go to polar. And when you do polar, remember it's r comma theta, and the theta value has to be in between 0 and 2 pi. So first I'm going to graph the thing to find the quadrant I need. So positive 1, 2, and then down 2. So it's going to be down here, right? Somewhere. I'm in the 4th quadrant. There's my right triangle. The x value is 2. The y value is negative 2 root 3. Okay. To get the r value, you have to use the Pythagorean formula. R squared equals x squared plus y squared. Okay. So you'll have then r equals the square root of 4 plus 4 times 3 is 12. So that we square root, made this one easy, 16 is 4. So it's 4 comma. Then I need my angle. To get the angle, you have to go to your tan formula. Tan of, in this case, y, which is negative 2 root 3 all over x. So I'm looking for an angle theta such that tan of that angle is equal to negative root 3. And that will be in the 4th quadrant, right? So theta, in that case, we need a version of pi over 3. And in that quadrant, it would be the 5 pi over 3. Okay. So it would be 4 comma 5 pi over 3. Okay, then we want to be able to convert equations back and forth. So convert equations back and forth. So you should have an equation that's in terms of x and y. So something in terms of x and y. And then you want to turn it into an equation in terms of r's and thetas. And the x and y formula, in general, you're hoping to get something like f of x equals y, right? And for the theta, r theta, for the polar coordinate place, you usually want something that's like a r of theta equals, or rather, let's put a, I forget which letter they used. Oh, crud. I'm sorry. Let's just use f of theta equals r. Okay. So you should be able to go in either direction. I don't know why I changed colors there, just by accident. Okay. So let's take a look here at some standard ones. So going first rectangular to the polar, number 55, you have x minus 2 squared plus y squared equals 4. So ideally, I want to end up with something that's r equals something in terms of theta. Okay, I want to end up with something like this, with r equals. Okay, so the only formulas I have then for converting x into y will be the x equals r cosine theta, and then the y equals r sine theta. Okay, so let's put those in the places. I'll have r cosine theta minus 2 squared plus r sine theta squared equals 4. And then I'm going to FOIL that first guy out, so I have r squared cosine squared theta minus 2r cosine minus 2r cosine is 4r cosine theta, and then plus 4 plus r squared sine squared theta equals 4. These two guys will form one of your Pythagorean identities, right? So you could factor an r squared out of them, and you just have cosine squared theta plus sine squared theta, and that just ended up being r squared, right? And then minus 4r cosine theta plus 4 equals 4. And then, like I said, this would be 1. So you'd have r squared minus 4r cosine theta plus 4 is 4. Move that 4 to the other side. That'll give you a 0 there. And then this is the kind of the weird part that you may or may not remember. You want to factor this. Okay, so it's r times r minus 4 cosine theta, and then you set the parts equal to 0. So r is 0, or r minus 4 cosine theta is equal to 0. And then solving the second one, you get r is 4 cosine theta. You could leave it like this. Technically, you're supposed to throw this part of it out, okay? Because this formula will give you that point. So this r equals 0 just gives you 1 point, okay? R equals 4 cosine theta will give you that point. In particular, when theta is equal to pi over 2, r will be equal to 0. So you'll end up plotting that thing anyways, and you won't have to worry about that other bit, okay? Okay, but I'll accept either solution if you just let it like that. You know, I'm pretty flexible at this point. You probably haven't had a lot of experience with polar graphs, right? So I'm comfortable with bending a little bit on my test. But hopefully you're getting something like r equals something in terms of theta. Okay. Okay. Going in the other direction then, let's say this is the easiest one in the universe, r equals 8. And use the formula r squared equals x squared plus y squared, right? And so in this case, we'll have 8 squared equals x squared plus y squared. And then x squared plus y squared will be 64. In other words, it's a circle with radius 8. Okay. Okay. Let's move now into 6.4. And in particular here in this section, I want you to be able to graph these polar equations, okay? So stuff like 13 to 27, and in particular, circles and rose petals mainly. I don't think I'll give you any snails. So just circles you should be able to do. So circles like this Those are the easy ones. Circles like this, or rose petals. Okay, we all know rose petals kind of look like these. Okay. So let's look at two versions of those. Here's number 13, r equals 2 cosine theta. And on the test, I expect to see two things. I expect to see, number one, you're doing either a table or you're doing a graph in the r theta plane. And then number two, I expect to see the graph in the xy plane with all your circles and your angle lines. Okay. Okay. So first, I like to do the graphs. So first, the amplitude is 2. Secondly, the period going from 0 to 2 pi. And then thirdly, the tick marks, just take that and divide it by 4. So 2 pi over 4. So I'm going to be going by pi over 2s. So my theta r, and my theta r plane, it's a cosine function, so it starts out at 2 and then dives down, and then dives back up. And we're going by pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, and so on and so forth, right? 5, 6, 7, 8. If I need any more, I don't know. Then I'll go over to my xy plane and do my concentric circles. If you need any extra sort of tick marks on there, or diagonals, like pi over 4, if you want to put that in there, you can. But at this point, then, I'm going to go ahead and draw the thing. So I start out at 0 at angle theta equals 0. I'm at 2, so I'll be right here. And then it dives down to 0 at pi over 2. So it's going to have this curly kind of form to it. And it gets to 0 at pi over 2. That's going from here to here. Okay, and then from pi over 2 to pi, it's going to -2. So it actually goes on to the negative side over here, and it's plotting. And it'll go out to -2. So it kind of just goes back out to here. And that's the whole thing. And then after you get into this quadrant, it's just going to climb back to 0. In other words, it's retracing itself. Okay, so at the end, you just have a circle. It's this form here with radius 1. Okay. Okay, let's look at 27. And looking at this guy, because it has that weird 3 theta on the inside of it, that means it's a rose petal. So again, first I get the amplitude. That's A is 4. Secondly, the period. So we wedge this in between 0 and 2 pi, and then we can divide out by 3. And then you get your tick marks. So I got 2 pi over 3 divided by 4. In other words, multiplied by 1/4. So canceling, I get 1, 2 there. So I'm going by pi over 6s. I go over to my theta r plane, and I have 1, 2, 3, 4, 1, 2, 3, 4, going by pi over 6s. And sine starts at 0, and then zips back up, and then back down, and then back up. Let's see if I need any extra ones. 5, 6, 7, 8, 9, 10, 11, 12 pi over 6, because I usually just go at 2 pi. 12 pi over 6 is the same as 2 pi. And then I'm going to go to my xy plane, and I should see all of this, so you don't short change me. 2, 3, and then 4. And then you get some radial lines. I'm going by pi over 6s. Well, pi over 6. 2 pi over 6 is the same as pi over 3. And then 3 pi over 6. 4 pi over 6 is 2 pi over 3. 5 pi over 6. And then we should be good enough, right? So 1 pi over 6, 2, 3, 4, 5, 6, 7 pi over 6, 8, 9, 10, 11, and then this will be 0 and 12. Okay. Okay, let's do this one in red. So I start going from 0 to pi over 6. It's going from 0 and increasing to 4. Okay, so it starts at 0 and then increases to 4 at 1 pi over 6. And then from pi over 6 to 2 pi over 6, it decreases back to 0. Okay. So that was from here to here, and then from here to here, and then from here to here. So 2 pi over 6 to 3 pi over 6, 2 pi over 3 pi over 6, it goes negative. So it jumps out into this region below. Okay. Oops, wrong one. So that would be for 2 to the 3. I'm going actually 3 to the 4, so it's in this region. Okay. Because it's negative, it's on the other side. So let's just make sure. Wait. I'm already lost. 2 to the 3 is negative. So yeah, that is in this quadrant. 2 to the 3. And then 3 to the 4 will be kind of in quadrant 9 to 10, or sector 9 to 10. Okay, so 2 to the 3, it jumps out to -2. So 2 to the 3 is right here. Jumps out to -2. And then 3 to the 4, it goes back to 0. So right here, goes back to 0. And then 4 to the 5. Okay, so 4 to the 5, I'm jumping back out to 2. Okay. And then 5 to 6, it goes back to 0. So it goes back to 0. And then 6 to 7, it's going out to -2. So now I'm on the other side of the arm. I'm actually in this sector here again. But that means I'm repeating myself, right? So I'm just going over that. So I went from 0 to 6 pi over 6, and that's the complete picture. Okay. Let's move on to 6.5. So in this section, we're working with complex numbers, and we're able to get a new form for the complex numbers. We also talked about graphing complex numbers, and because we worked in the polar coordinates, we get a polar type form for the complex numbers. Okay, so 11 to 41 odd, 53 to 59 odd, and the first type of problems I'll be thinking of will be like converting to polar form from the traditional rectangular form, like number 17. So here is a rectangular form, and I'm going to need to plot it, and then that will turn into the form, r times cosine theta plus I sine theta. Okay, so I'm going to plot it, figure out my quadrant. The theta has to be in between 0 and 2 pi. And a lot of this stuff works the same way it worked in the polar coordinates. Okay, so anyways, positive 2 root 3, and then down to -2. Sorry. So it'll be like this. It's 2 root 3, and then -2. I'm in the fourth quadrant. The r value, r squared, is x squared plus y squared. So x squared will be 4 times 3, plus -2 squared is 4. So r squared, again, is 12 plus 4 is 16, so r is 4. So you get 4 times cosine of blank plus I sine of blank. And for the angle, then, you just use the tan of theta formula. Tan of theta is y over x. So I'm looking for an angle theta such that the tan of that angle is equal to -2 all over 2 root 3. Which is -1 all over root 3. It needs to be in the fourth quadrant, and of course that'll be some variation of pi over 6. So 11 pi over 6 to get me into the fourth quadrant. Okay. And that's it. Let's work with multiplying these things out. So I give you the formula for multiplying, I think, on my I lost my page. I'm so sorry. Let me log in. Please let me log in without typing in my password. Let me go to Blackboard if I can find it. Uno momento, please. This is 40 course content. Being able to navigate through the internet is such a good skill to have. Right, so I guess I don't give you the formula for multiplying. Do I? No, I don't. I give you the power formula. So I think that there will be power problems and probably no multiplication, but the multiplications are pretty easy. You just kind of have to, it turns into addition, right? So you have to kind of add the angles together in the formula. But the power formula is there for you. Number 57 is a power problem. So let's take a look at that. 57. So we have 1/6, or rather 1/2 times cosine of pi over 12 plus I sine of pi over 12. I'm not going to put any of the Moivre's formulas on there where you're finding the roots. Those are usually a lot harder. Anyways, when you do a power, you raise the r part to the power, so it's 1/2 to the 6. And then for this, it turns into to just multiply the 6 times the pi over 12. Okay, so 6 times pi over 12 is the same as 6 pi over 12, which is the same as pi over 2. Then I get plus I times sine of pi over 2, the same sort of thing. So 2 times 4, 8, 16, 32, so 1 over 32. And then times, we got to put it in the rectangular form, okay? So anyways, cosine of pi over 2 is 0, plus I times sine of pi over 2 is just 1. So this will be just 0 plus 1/32 I, or you could just write it as 1/32 I. Okay. I don't think I put any multiplication on the test, but you may want to just remind yourself of that formula. I'm looking it up to make sure I don't accidentally tell you wrong. Multiplication is just addition of the angles, right? Multiply the r's and add the angles. Yeah, so if you had, like, let me find a problem in the book. Sorry, I neglected this in my review. We want to multiply something like number 41. And make sure you're going into the book and reading the questions. Find the product of the complex numbers, leave your answer in polar form. So in this case, Z1 is given as cosine of pi over 4 plus I sine of pi over 4. And then Z2, there's no R value here. Let's make it a little different. So like 41. We'll make this 3 cosine of that. And Z would be, let's say, 4 times the cosine of pi over 3 plus I sine of pi over 3. Okay, so it's pretty easy. All you're doing is kind of, when you multiply Z1 times Z2, you're multiplying, yeah, the R values together, 12. But then for the angles, you're adding them. Okay, so it kind of transforms. If you think of it geometrically, what's happening is when you multiply two different numbers, you're kind of just adding their angles together. Okay, so to multiply this times this, it'll kind of rotate over to a new answer, and then it'll also extend the R value. Okay, so it's kind of weird geometrically, but that's not something we're all that concerned with. So anyways, pi over 4 plus pi over 3, and then plus I sine pi over 4 plus pi over 3. And then we could write that as, we want to leave it in polar form this time, so it's just cosine, find a common denominator, 12 and 4. So this would be 7 pi all over 12 plus I times sine of 7 pi over 12. And that would be it. Okay. So I don't think there's one of those on the test, but just to be sure. You may want to have that memorized. 6.6, we get into vectors, okay, vector addition, subtraction, and scalar multiplication of vectors. So 13 to 45 odd. The first kind of problems, I need to be able to take two coordinates and transfer those into a vector. So like number 17, we have P1 is -1, 7, and then P2 is -7, -7. To get the vector P1, P2, and order matters here. So it's always you take the second coordinate of the x value and subtract away the first coordinate from, you take the second point's x coordinate and subtract away the first point's x coordinate, sorry. So -7 minus -1 for the first coordinate, and the first coordinate we give the standard unit vector I, and then plus, you take the second, so it's a little bit like slope, right? You take -7 minus 7, and that will be your j. Okay. So I end up with -7 plus 1 is -6i, and then -7 minus 7 minus 14j. Okay. All right, let's do another one. So the book says let u equal 2i minus 5j, and then let v equal -3i plus 7j. We need to figure out, in problem 32, we need to find 3u plus 4v. Okay. So to do scalar multiplication, you're just going to multiply the components by, in the first case, 3. So you multiply the components of u. By the components, I mean here's the first component, here's the second component. Okay. So by 3, I'll have 6i minus 15j, and then plus, then you multiply the components of v by 4, so I'll have -12i plus 28j, and then you add the like terms together. So you get 6 minus 12 is -6i, -15 plus 28 is plus 13j, okay, and that would be your final answer. Unit vectors are important. So a unit vector is a vector that has length 1. And basically all you have to do is find the magnitude of the vector and then divide the original vector, or rather multiply the original vector by the reciprocal of the magnitude. So 43 is vector v equals 3i minus 2j. And I want to turn that into a unit vector. So the unit vector will be basically 1 all over the magnitude of v times the vector v. So the magnitude of v is something that's important. We need that. That's just the square root of the square of the components. So 3 squared is 9, -2 squared is 4, so that'll be square root 13. So this will be 1 all over square root 13 times 3i minus 2j, which you can write then as 3 all over root 13, I minus 2 all over root 13j, and you could leave it in that form if you have better things to do. You don't have to rationalize for me. I am not high maintenance. Okay, the last section then, we introduced finally the idea of multiplication, in particular the dot product. Okay, and the dot product is actually not another vector, but it'll be a scalar. Later on in math, you get the cross product, which will result in another vector, but for now we just have the dot product. And the dot product was a measure of the alignment of vectors. So in particular, we could of course correlate that to angles between vectors and that sort of thing. For physics later on, we need to be able to do projections, so I also need to make sure you can find the projection of a vector. Okay, so let's look at some of these problems next. 6.7, looking at problems like 17 to 37. The first kind, find the angle. Find the angle between the vectors. And I believe I give you this formula on your sheet, but let's copy that on the problem first. So the vector v is -3i plus 2j, and the vector w is 4I minus just plain old j. Let's see if I got the formula on the formula sheet. Yeah, I do. It's right there. The cosine theta equals that dot product over the magnitudes. So I have cosine of the angle between the vector is equal to the dot product. So dot product just multiply the components and add them together. So negative 3 times 4 is negative 12, plus 2 times negative 1 is negative 2, all over the magnitudes. So square root of negative 3 squared is 9, plus 2 squared is 4, times 4 squared is 16, plus negative 1 squared is 1. Okay, so I get negative 14 all over the square root of 13 times the square root of 17. Then theta will be cosine inverse of that. Whatever square root of 13 is 221, I think. 221. Okay, so in this case, if you put that in your calculator, make sure you're in degree mode, you get 160 degrees. Okay, one other question was orthogonal. Like if cosine of the angle between them actually equaled 0, like in this case, that would mean that theta was pi over 2. In other words, the angle between the two vectors was 90 degrees. In other words, they were orthogonal. So I may test you in determining whether two vectors are perpendicular or orthogonal. Vectors are orthogonal. And number 26, they give us the vectors. V is 8I minus 4j, and W is negative 6I minus 12j. All right? Sure, I'm still recording. Yeah. Okay. So you could just take the dot product, v dot w, and if it equals 0, you're done. So let's see, 8 times negative 6 is negative 48. And then plus negative 4 times negative 12 is positive 48. That's equal to 0, you're done. So they are orthogonal. They are orthogonal. So make sure I can read it. Okay. Okay. Find the projection. So we need to be able to make sure you know how to find a projection. Projection of V. Let's just use the same vectors. Well, actually, let me take one from the book. So find the projection of V on the W. So 34. V is given as 3I minus 2j. And then W is given as 2I plus j. And what I'm going to do is go to my formula sheet because I know it's in there. Okay, there's my projection formula. You need a dot product up top. So projection of V onto W. Usually if you take my later class where we actually use this, I'll have you memorize the formula. Okay, so but for now I just kind of put it in your formula sheets. But anyways, in the numerator there's a dot product, so it'd be 3 times 2 is 6, plus negative 2 times 1 is negative 2. And then in the denominator, it's the magnitude of W squared. So it just turns out to be 2 squared is 4, plus 1 squared is 1. And you'd have a square root, but it's supposed to be squared in the formula, so the square root goes away. And then times the vector W. So you get 2I plus j. Okay. So 6 plus negative 2 would be 4 all over 5, and then times 2I plus j. And so that would be 8/5 I plus 4/5 j. If I ask for the orthogonal, for the other component, so remember we kind of called this one V1. If I ask for V2, you can find V2 by just doing the subtraction. Take V and subtract away V1. Because ultimately, if you have a vector V, you can add V1 and V2 together to get that vector. So V1 would be this, V2 is this, and you're adding vectors, you put them tail to tail, okay, and you get vector V. So V would be V1 plus V2. In other words, V2 is equal to V minus V1. Okay. vector symbols in there. So if you need to, V is equal to 3I minus 2J, and then we're subtracting away V1. Common denominator, so this would be 15 fifths, this would be 10 fifths, and that'll end up giving us 7, I don't know why that's taking me so long, 7 fifths I, then minus 16 fifths J. Right? Negative 12, oh, that's a 10, sorry. So negative 10 fifths minus 4 fifths is actually negative 14 fifths. Okay, so expect, to study for the test, what you do is just go to the book, go back to the beginning and find problems, similar to the problems I just did in the video, and make sure you can handle them. You can even make up your own test and practice it before you actually take the test and get a really good grade. Okay, so if I did number 10, try number 11. If I did 15, try 16. If I did 18, try 19. Try 24, try 27. And then just go through the whole book, the whole review that way, and you probably will have hit all the problems that are similar to ones on the test. You'll be very, very prepared. Make sure you're reading the questions in the book. I take my questions directly from the book, and hopefully that'll get you through the test with a good grade, and we'll see you next time. So good luck.